All right, ladies and gentlemen, if I could have your attention back up to the screen. If you guys remember from where we left off last week, I'm just going to go ahead. You don't have to pull these up, but I do want to just direct your attention to what we did. Last week, we saw that rational functions, those are functions that are fractions. We saw that they could have vertical asymptotes. And the vertical asymptotes is really the vertical line. It comes from the denominator, what would make the denominator equal 0. And all the points on the graph will approach that asymptote, but not touch it. And then we also looked at holes, where if the graph has a hole, it's just recognized as a little open circle on the graph. And then you'll see here that the points are going to surround it, but it's not an actual point on your graph. Well, the last thing we have to talk about are horizontal asymptotes. And just looking at this picture that we did last week, you're probably able to see from our sketch that this function has a horizontal asymptote. That's an invisible horizontal line the points are approaching. Same with this one. It has an invisible vertical or horizontal line that the points are approaching. Today, we're going to see how do you know what that line will be. And really, there's 3 things that we have to consider. So that's where we move into today's notes, which is looking at horizontal asymptotes. When you're looking at a horizontal asymptote, first let's study what it is. Horizontal asymptote values align with what the y values of a function are approaching as x goes to infinity, or you could say negative infinity. So we're going to look at 3 different functions, and this represents the 3 different cases that could occur in a rational function. And we're going to look at the table to see what's happening to the y values as x gets really, really big, or as it approaches infinity. So looking at letter A, notice I was going to originally have you guys complete this table, but I'm more concerned with, can you see what's happening in the table? So let me show you what's happening, and then I'll ask you kind of some questions. So I want to see in this function, what's happening as x gets really, really big. So we're plugging in these values of x into that function to determine the corresponding y value. For example, if I plug in 100, if you did 100 divided by 100 cubed on your calculator, you would find the answer to be 0.0001. There's 3 zeros and then a 1. If you plug in 200, you're going to get 4 zeros and then 2 5. If you plug in 3 zeros, you're going to get 4 zeros and then 1 1. If you plug in 400, you get 5 zeros and then 6 3, and you're going to see the values continue in the way that they do. When you plug in 900 into this function, the y value that comes out is now 0.00000012. As you plug in even bigger numbers for x, so let's think about x as it approaches infinity, as it gets really, really big. What does it look like the y values are getting closer to, or what are they approaching? We have 3 zeros after the decimal, then 4 zeros. Most likely there's going to be a lot more zeros and then some number. What is that number really close to? 0.00000000. 0, exactly right. So the y values are approaching 0. So in a case like this, y is approaching 0. Specifically, what happened in the equation that made that happen is the degree of the numerator. Do you guys remember the word degree? What is degree? The exponent. So the degree of the numerator, or the exponent of the numerator, is 1. The exponent of the denominator is 3. When the degree of the numerator is less than the degree of the denominator, this will always happen. The y values will always get closer and closer to 0, which means we'll have a horizontal asymptote at y equals 0. I want to show you what this looks like on a graph. You do not have to reach for your calculator. In fact, I'm going to be showing you by hand how to do this without a calculator. But some people I found were confused with what is a horizontal asymptote? What does that look like? So I just want to show you what this will look like on the actual graph. So if I go to y equals and I typed in this function, which is x over x cubed. And then I graphed it. Do you guys see an invisible horizontal line at 0, at the y value of 0? See how like all those points are getting really, really close to it? They're never going to touch it. They're just going to get closer and closer and closer to 0. This will always happen when the degree of the numerator is less than the denominator. If you didn't quite understand how that happened, then I would just go to this part of the box and say, this is something that I have to have memorized. When the degree of the numerator is less than the degree of the denominator, the function will have a horizontal asymptote at y equals 0. Just like the example above, where the degree of the numerator was less than that of the denominator. Okay, what happens when the degrees don't work out in that way? In fact, look at letter B. What's happening, or if I look at the degree of the numerator, what's the degree of the numerator? I could say, what's the highest exponent of the numerator? What would you say? 1, awesome. And what's the degree of the denominator? Also 1. So in this case, they're equal. The degrees are the same. So let's see what's happening to the y values in this function. If I plugged in 100 into this function, 2x plus 1 over x, I would do 2 times 100 plus 1 divided by 100, and I would find on my calculator that the answer came out to be 2.01. If I plugged in 200, I would get 2.005. If I plugged in 300, I'd get y equals 2.0033. If I go all the way up to 900, I would find it to be 2.0011. If I plugged in a really, really, really large number, and I'll just say as x goes to infinity, the y value would equal 2 a ton of zeros. So what number is the y approaching?
0.
Awesome, it's approaching 2. And that's what you wanted to be able to see in the table. The y approaches 2. Now, if you're looking at, well, where did 2 come from in the equation? 2 is actually the numbers in front of the x. Notice that this number's 2 and this number's 1. That's what the horizontal asymptote will be if the degrees of the numerator, or if the degree of the numerator equals that of the denominator. So in this case, the horizontal asymptote is going to be y equals 2, but you might even just want to write 2 over 1 so you can see where those numbers come from. I'm going to show you this function just so that you can see again that asymptote on the calculator. So if I did alpha y equals 2x plus 1 over, what was it, x, and then I graph it. Do you guys see when y is equal to 2, there's an invisible line here going all the way across? So that's what happens when the degree of the numerator equals that of the denominator. And again, it's explained in this box right here. When the degree of the numerator is equal to the degree of the denominator, like this here, 1, 1, 1 equals 1, then mathematically, you would say the horizontal asymptote is y equals a over b, where a and b are the coefficients, those are the numbers in front, of the terms with the highest degree in the numerator and denominator. If you know your math terms, you could just say it's the ratio of the leading coefficients. So in this particular case, it would be 2 over 1, y equals 2. Okay, that's case 2. There's only one other case that could occur. We looked at the degree of the numerator being less than the denominator, equal to the denominator. The last case is where the degree of the numerator is greater than the denominator. And again, we have to ask what's happening to y as x gets really, really, really big. Well, just so you understand what's happening in this table, the y values come from this function, x cubed over x. So if you plugged in 100 and you did 100 cubed divided by 100, you would get 10,000 to come out. If you plug in 200, you're going to get 40,000 to come out. If you plug in 300, you're going to get 90,000 to come out. When you keep going and keep going, when you plug in 900, you're going to get 810,000 to come out. What are the Y values approaching? Awesome. It approaches infinity. It keeps going forever and ever. So as X gets really big, Y gets really big. So there's no leveling off. No leveling off. That's important to understand because in this case, Y is approaching infinity, which means there will be no horizontal asymptote. Nothing that they're getting close to. In fact, if I was to graph this, you're going to see it's just increasing forever. If I do, I'll go ahead and show it to you, x cubed over x, and then I graph it, I'll see my function eventually. Will I? Did I see it? Oh, there it goes. It's just super slow. Notice how there's no level, there's no straight horizontal line across. This graph's just going forever and ever up and down. That's because the degree of the numerator is bigger than the denominator. Okay, so that's the final case. If the degree of the numerator is greater than the degree of the denominator, there will be no horizontal asymptote. Okay, let's practice this with 6 examples, and then we're going to put it all together and see how do you graph a rational function by hand. So example 3, find the horizontal asymptote, if any, for each of the following. Letter A, what would be the degree of the numerator?
1.
So this you want to be careful with. If it's 1, then you'd have an x to the first. So what could we say if we don't have an x there? Could I say x to the 0? Well, what is any number to the 0 power? Well, let's think. Let me look at this. If I said, what is 2 raised to the 0 power? It's 1. We learned that a long time ago at the beginning, but that is something that's good to know. Any number to the 0 power equals 1, which means if you don't have an x there, you could add in an x to the 0, totally valid. Now, if I look at the denominator, what's the degree of the denominator? There's nothing next to the x. What's it understood to be? 1, good. So the degree of the numerator is 0. The degree of the denominator is 1. 0 is less than 1. So that's going to be where I start. The degree of the numerator is less than that of the denominator. Therefore, look back at the 3 cases. Which one does this match? Where will we have a horizontal asymptote at? Awesome, y equals 0. This matches case 1. So I would just say y equals 0. Letter B, what is the degree of the numerator? 1, what's the degree of the denominator? 1, awesome. So the degrees are equal, 1 equals 1. So looking at the 3 cases, this is going to match case 2. Therefore, we're going to have a horizontal asymptote. Case 2 says y equals a over b. Do you know where we get a and b from this equation? The coefficients, awesome. So I'm going to take the number 1 because that's in front of the x. And what's in front of the x in the denominator? 3. So our horizontal asymptote is going to be y equals 1/3. Okay, let's do one more together. Letter C. What's the degree of the numerator? 1. What's the degree of the denominator? 2. Awesome. So if I think about the degrees, 1 is less than 2. Look back at the 3 cases. Really, you want to be looking at case number 1. If the degree of the numerator is less than the degree of the denominator, then horizontal asymptote at y equals 0. So I would go ahead and say y equals 0. Okay, looking at the next one, letter D. The degrees are the same because 2 matches 2. Look at the 3 cases in your box. Write down what you think the horizontal asymptote will be. And turn to your partner and the person with the youngest sibling. You share what you think the horizontal asymptote would be at. Landon, you're the oldest, right?
Yeah, I am.
So you have a younger sibling. How young is the youngest?
The youngest is 9.
9. Okay. My youngest sibling is 27.
Yeah.
I think you win.
So
You know,
wouldn't I'm kind of confused on how to start with it.
so you start with the degree. The degree of the, do you know what the degree means?
Isn't it the squared?
Yep. The degree is the highest exponent.
Mm-hmm.
And since the degrees are the same, that means it's going to match case number 2 in the box.
Okay.
And case number 2 says if the degree of the numerator is equal to that of the denominator, then it's going to be A over B. Do you know where we get A over B?
Isn't it by like dividing?
Yep, it's the numbers in front. So you would
Okay.
do 3 over 1. So it'd be y equals 3.
Okay.
All right, guys, take a look. You should have a horizontal asymptote at y equals 3. Do we get it? Margot? Because the degree is always the highest exponent. And because this is in standard form, we don't add them up because we're not multiplying them together like we did it if it was multiplied out. So you look for the highest exponent there. Good question. Any other questions, guys, before we move on? All right, let's look at letter E. Letter E, what is the degree of the numerator? Hold up a finger. I want to see if we know how to determine the degree. What is the degree of the numerator? You just see all fingers up, or I'm going to explain. Okay, I saw most confidence. 1, your degree is your exponent. So if you're like, what is all that math language? It's your exponent. That equals your degree. And really, it's the highest exponent. So the degree of the numerator is 1. The degree of the denominator is 3. Since the degree of the numerator is less than the denominator, you go up to the box. This would be case 1. And that means you're going to have a horizontal asymptote at y equals 0. Letter F, it's a little bit tricky because letter F, it's not multiplied out for you. And when you're looking for the degree, it does have to be multiplied out. So as I think about this, you don't actually have to multiply it out, but you have to multiply it out enough to where you can see the degree. So if I'm doing x times x, what would that create? Good, x squared, and then there's a bunch of stuff after, which I'll be honest, I don't really care about. And then if I look at the denominator, I have x plus 2. The degree of the numerator is what? Hold up a finger or multiple. What is the degree of the numerator? 2, awesome. The degree of the denominator is 1. Since the degree of the numerator is greater than the denominator, this is the only case we haven't looked at yet in all 6 examples. This would be case number 3, which my OneNote always takes a while to, if the numerator is greater than the denominator, then none, no horizontal asymptote. So there would be none here. All right, you have all the information you need to put it all together and be able to sketch by hand. So let's go ahead and let's do that. On to the following example. Find the vertical asymptote and horizontal asymptote and holes, and then sketch the graph. All right, first things first. You will want to set the denominator equal to 0 and then solve. So if I set x plus 3 equal to 0 and I solve, subtract 3, I'll get x is equal to -3. Is that a vertical asymptote or a hole?
Vertical asymptote.
Awesome. How do you know it's a vertical asymptote? Awesome. It doesn't cancel. It stays put. Okay, so with that said, do we have any holes? None. How do you know we have none? Awesome, because nothing cancels. Sweet. On to our horizontal asymptote. That's what we just learned. So look at the numerator and the denominator. What's the degree of the numerator? 1. What's the degree of the denominator? 1. So if the degree of the numerator equals that of the denominator, if you don't remember because it's brand new, then the horizontal asymptote is at the ratio of the coefficients, A over B. Where do I get those numbers, A over B? Do you know? Where do I get those numbers? A over B. The coefficients, awesome. So what's the coefficient of X? 1 and 1, so it'd be Y equals 1 over 1, or just 1. Okay, let's sketch those two things to see what will those look like. If I sketch X equals -3, I know that that's an invisible vertical line. All the points are going to go towards. So when you're graphing it, you're just going to do it as a dashed line, and it's going to kind of give you your framework of where your points will get really close to. So this is X equals -3. And then I also need to graph my horizontal asymptote. So Y equals 1. So at 1, I'm going to draw a horizontal line. And this is going to give me my framework because I know the points are going to get close to these lines, but never actually touch them. For all graphs, you need to know how to find the X and the Y intercepts. X-intercept, how do you find it? What do you set equal to 0? Good, set Y equal to 0. So if I'm looking at my equation, you do have to recognize that this is the same thing as saying Y equals X minus 5 over X plus 3. So I'll go ahead and recopy that equation right here. Y equals X minus 5 over X plus 3. I'm going to set Y equal to 0. So I'm going to put in 0 for Y, and then I'm going to solve for X. Here's the beauty of X-intercepts. You actually don't ever need to write down the denominator. I can multiply this by X plus 3, this by X plus 3. That will cancel. What's 0 times anything? 0. So did I need to write down the denominator? No, it'll always multiply away. So I have 0 is equal to X minus 5, and then I solve. So I'm going to add 5 to both sides, and I get X is equal to 5. How do I write that as a point? Nice, 5, 0. And then I'm going to go ahead and I'm going to plot that point on my graph. This is a point that is actually on the graph, and it's on the x-axis, hence x-intercept 5, 0. Okay, now let's go ahead and find the y-intercept. The y-intercept, how do we do that? What do you set equal to 0? Nice, x equal to 0. So I'm going to take that equation, and now I'm going to plug in x as 0. Y is equal to 0 minus 5 over 0 plus 3. Which will simplify to be -5/3. But that's going to be better to write as a mixed number. How do you write -5/3 as a mixed number? Okay.
-1 and 2/3.
Nice. Awesome. So then we have the y-intercept 0, -1 and 2/3. And I can go ahead and sketch that. So write down 0, -1 and 2/3 of the way to 2. And there's my y-intercept. Now I'm going to do a lot of writing to help you remember how to do this again in the future, but this is probably the only time I'll be writing a lot. When I'm sketching this graph, I know that these 2 points lie on my graph. I also know that my points are going to get really close to the horizontal asymptote, but not touch. So over here, as x goes to infinity, they're going to get really close to and kind of level off at that value. Same with the vertical asymptote. The points are going to get really, really close to, but never touch. So that's how I finish that part of the graph. Just go ahead and make a note with 2 arrows that the points on the graph always get close to the asymptotes but don't touch. Okay, a little bit more food for thought. How do I know that the graph will this is a function, right? It says f of x. It's a function. So with that said, how do I know that the graph isn't going to exist up here? If it existed up here, what test would it not pass? The vertical line test. If it's a function, it can't cross twice. So that's it for the right side of my graph. I know that that part of it is fully graphed. If you want to make a note of that, that might be helpful as you're doing your homework tonight. No function up here. Otherwise, wouldn't pass the vertical line test. Okay, I'm so almost done. The only other question that I need to, that remains is the function going to be up here or is it going to be down here? And there's only really one way I can determine it. I know the function. I know how to find every single y. I know that y is found by taking x minus 5 over x plus 3. So how can I determine what happens on this side of the graph if I know how to find every y? How can I determine what happens when x is -4? Or when x is -5? Or when x is -6? You have the answer. You have how to find y. How can you create any graph without knowing anything about it? What could you plug? What did you guys use in the past when you were first taught graphs? Did you guys use tables? Yes. Do you remember tables back in the day? So if you are trying to determine what happens over here, you really need to use a table to determine what happens here. So I'm going to go ahead and use a table, x, y. What do I have to plug in into the table for this side of the graph? Would you plug in a number like 8? Hopefully you're thinking no, because I already have that side. So what would be a good number to plug into the table?
-6.
Awesome. -6, -5, -4, any of those would be good. I'll go ahead and plug in -4. That works. But you just have to see that it's along this side. You could have chosen any of these numbers. You could have even chose decimals. But I'm going to plug it in for y to see what happens. So I would have -4 minus 5 over -4 plus 3. That gives me -9 over -1. What's a negative divided by a negative? Positive, so that answer comes out to be 9. So I have the point -4, 9, which is way up here. Once you have one point, you could plug in more points to a table. But if you understand vertical asymptotes and horizontal asymptotes, you know that the graph's going to get close to those, but never reach it. So it's going to get close to it, but never reach it. And there's that other side. Now you could have plugged in more points. Like I could have plugged in -8 or -9 to see what happens, but it will continue in that way because it always gets close to the asymptotes, but it doesn't touch it. All right, on to numero dos. Number 2, what do you think we have to do before we can actually sketch this?
Write out all the stuff.
Write out all the stuff. How do I figure out the stuff? What do I need to do with x squared minus 4? Factor, good. So we're going to have x plus 2 over quantity x plus 2, x minus 2. Then set your denominator equal to 0 and solve. With your partner, see if you can determine the VA, the whole, and the HA. I'm going to walk around. If you need help, let me know. But see if you can determine the VA, the whole, and the HA. We got 3 minutes. Oh, geez. We're gonna go over it. Okay. All right, guys, take a look. X equals 2 should have been a VA because x minus 2, where it came from, didn't cancel. The whole, it's going to be an ordered pair. You don't need to write the word ordered pair, but you need to have the x value at -2. To determine the y value, we need to reduce this function. What's any number divided by itself? 1. So this is going to become 1 over x minus 2. So I'm going to plug y equals 1 over x minus 2. I'm going to plug -2 in for x to determine the y value of the whole. So the y value of the whole is going to be 1 over -2 minus 2, which is going to be -1/4. The horizontal asymptote. Did you guys figure it out? What should it be at? Awesome, y equals 0, because the degree of the numerator was less than the denominator. So as I'm sketching this, I'm going to have x equals 2 as a vertical line. Y equals 0 is a horizontal line at 0. And I should have a whole at the location -2, 1/4. So that's just an open circle at -2, 1/4. I often have people ask me, when I'm finding the x-intercept, should I use the original function or the reduced function? I'm going to show you that it doesn't matter. I'm going to show you it on both. Actually, because time is running short, I'll tell you, use the reduced function. It's easier. Use the reduced function. It doesn't matter what you use, but I'll be honest, the reduced one is always the easiest to work with. The reduced function we found was 1 over x minus 2. So to find the x-intercept, you set y equal to 0. If I set y equal to 0, do I even really need to copy the denominator? No, because it's going to multiply out to both sides. And I'm going to get 0 is equal to 1. Is that possible? No, so that means there's no x-intercept. To find the y-intercept, you set x equal to 0. So I would have y is equal to 1 over 0 minus 2. That's -1/2. So my y-intercept is 0, -1/2. And then I can plot that. 0, -1/2. Here's another helpful hint. Your points always surround your whole. So the points are going to surround the whole. And then guys, the last thing you would have to do is plug it into a table. It's in the completed notes, but use the reduced function. And then you would plug in 3 into your table. And that would be it. All right, have a great rest of your day. Use the completed notes if you need it for that last piece, but the homework is a worksheet. Yeah. Do you have it on paper or do you at home? Okay. Oh, did you just submit it? Oh, do you want to just email it to me? Okay, that works. Yeah, have a good one. Oh, Josh, we have new seats. Hold on, I gotta give it to you.